What stands here is not a symbol of luxury, but the final outcome of a tightly controlled industrial manufacturing system.
Before this vehicle is approved, every critical dimension and structural interface is verified by machines against predefined industrial tolerances.
To reach this final state, the manufacturing process must begin at the structural level, where load paths, rigidity, and alignment are first established.
The structural fabrication of the aluminum space frame is the primary phase required to establish the vehicle's high torsional rigidity.
Precision MIG welding at these critical junctions ensures that mechanical load paths are distributed evenly across the entire aluminum architecture.
Automated laser scanners verify that every welded component remains within a sub-millimeter tolerance to prevent structural drift during assembly.
With the primary space frame fully welded and dimensionally verified, the structural core is now prepared for exterior body panel integration. The integration of individual body panels requires specialized hand brazing at the pillars to create a structurally continuous and seamless exterior shell. Thermal control and manual precision during the brazing process allow for a surface finish that eliminates any visible evidence of mechanical joining.
Every integrated seam is verified under specialized lighting to ensure the structural integrity of the shell before the application of surface treatments. The surface treatment phase establishes a permanent chemical bond to the aluminum architecture to ensure total resistance against environmental degradation.
Thermal curing completes the stabilization of the protective shell, providing a technically pure foundation for the subsequent application of the base coat layers. Automated centrifugal atomizers provide a density of coverage that manual application cannot replicate, maintaining a consistent micron-level thickness across the entire body. Electrostatic application reduces paint waste and ensures that even the most complex geometric nodes of the space frame receive an identical volume of pigment. With 5 layers of atomized coating applied, the body shell undergoes a controlled thermal cure to finalize the chemical bond and surface hardness. Sequential buffing with varying grades of abrasive media progressively transforms the matte industrial coating into a uniform reflective surface. Final surface verification ensures that the unbranded body shell meets the required geometric and reflective standards before the next integration stage. Each heavy-duty crankshaft is precisely balanced to eliminate vibration and ensure the characteristic smoothness of the large displacement power unit. Manual verification of valve clearances and bearing tolerances is conducted at every stage to guarantee absolute mechanical consistency. The completed V12 assembly undergoes rigorous static testing to confirm the integrity of all pressurized systems before leaving the sterile build zone.
Clearance looks good on the readout.
Confirmed. Lateral alignment is perfect.
The drivetrain marriage phase utilizes a high-force vertical installation to precisely seat the V12 power unit within the structural nodes of the chassis.
Controlled fastening transfers the load from the lift system to the chassis under exact torque specifications.
Once the powertrain is seated, torque-controlled fastening systems secure the structural mounts to finalize the mechanical integration of the engine to the space frame.
Woodwork engineering begins with the selection of raw veneers, where digital mapping ensures that grain patterns are suitable for precise symmetry.
CNC-guided cutting systems translate digital templates into physical components, maintaining sub-millimeter accuracy across the entire surface area of the panel.
Controlled thermal bonding under high pressure ensures a permanent, stable union between the natural hardwood veneer and the internal structural substrate.
Automated hide scanning systems detect microscopic imperfections and map usable zones to ensure maximum material structural integrity. Multi-axis CNC stitching ensures absolute geometric consistency across all interior components, maintaining a constant tension and stitch length.
Unbranded leather interior components. Phase 9 interior tailoring stage. Identity locked.
Post-stitching digital verification confirms that all seams and perforation patterns meet specified dimensional tolerances before subcomponent assembly.
The tailoring phase concludes with a final technical inspection, certifying that all unbranded leather components are prepared for final structural integration.
Automated drilling systems maintain coordinate accuracy across the surface area of the substrate.
Each individual strand is manually seated within a dedicated perforation to meet specific spatial requirements.
Mechanical verification confirms structural clearance and the integrity of the routed cable bundles.
Final verification ensures that physical positioning aligns with program tolerances within the specified assembly zone. Mechanical fixtures coordinate the lateral alignment of the fascia glass to maintain specified structural tolerances. Pneumatic sealing systems are pressurized to verify the integrity of the contact surface against the structural frame. Automated scanning verifies the seating coordinates of the seal to ensure uniform pressure distribution across the door aperture. The completed structure is subjected to sustained mechanical vibration to verify long-term stability. Across repeated cycles, the body maintains its specified geometry. Following dynamic testing, structural integrity remains unchanged.
What remains is balance, mass, and restraint.
The process ends. The form remains.
Next-Gen Machine Works, building the impossible. Subscribe to join the future.